कोण प्रीतीचा का? प्रीतीचा मला वाटते 9-10 महिने झाला असेल. हम्म.
Good evening to all. May I audible, sir?
Yes, sir. Yes, sir. Hello.
Hello. Okay, sir. Hello, good evening to all. Today's speaker, Dr. Chitranjan Naik, Head of the Department, Dean Autonomy and Associate Professor, Department of Civil Engineering, VP KBIET, Baramati, Pune. Sir has received research grant under the Savitribai Phule Pune University, Science and Engineering Research Board, DST, Government of India, and VH Khatri Construction Private Limited. Sir has achieved remarkable achievement. Sir has 7 sponsored projects undertaken and grant received, 8 patents and copyrights.
Okay.
May I audible, sir? May I audible? Hello? 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 Kati sir, hello?
Yes, sir. Yes, sir. Please continue.
Okay. 61 research papers published in international journals, 18 papers presented, published in international conferences, 16 papers presented, published in national conferences. Sir has 27 STTP workshop attended, 6 workshop conference organized, 9 national international programs courses completed. Sir has 20 keynote speakers, invited talks, session chairman, resource person. And sir has completed 28 book authors and chapter in edited books. Sir also sir has a key contribution to NBA and NAC accreditation activities. Naik sir, hello, over to you, sir. Naik sir.
Naik sir.
Hello.
Just a minute. Just a minute.
Hello. Hello.
Naik sir.
Just 1 minute actually. हमारे कॉलेज का अभी जाने का टाइम हो गया ना, तो इसके वजह से लोगों ने बाहर से स्विच ऑफ कर दिया करंट सप्लाई के. I'm just joining within 2 minutes.
Okay, okay, sir. Okay. Just a 2-minute session started. Also the technical problems also.
Sir, may I audible?
Yes, sir.
Okay. Thank you, sir. Actually, there is some problem in electricity. That's why it is at the time of your introduction. It's cut off by someone the electric cable. Okay.
Okay.
Can I start my session?
Yes, sir.
Yes, sir.
Yes, sir. Please.
Thank you, Professor, for the nice introduction, and I will start my session today. That is, today is my session about structural health monitoring, and that is concept, theory, and practical applications. I think I will, due to some unavailability of speaker, I will deal with this topic with two sessions. I think this is the first session, and later on we are going to see another. Today I am going to see the what are the structural going to deliver what are the structural monitoring and what are the concepts and theory, and the practical applications I will going to do in next session.
Mike,
Then to
Mike,
start
sir. Mike, sir.
yes.
जरा आवाज your
Low
Eco, sir.
audible.
echo sound.
Echo. Okay. I will do that. It is clear right now.
Yes, sir.
Yes.
Yes.
Sir, it is clear.
Yes, sir.
Yes, sir.
Please continue. Please continue.
Okay. My screen is visible, sir.
Yes, sir.
Visible to you.
Yes, sir. Yes.
Okay, thank you. So today is my topic is what are the structural monitoring, and that overview and applications are all things. Already Dr. Bobde and Kate sir is already introduced me. Right now I am working in civil department in Vidya Pratishthan College of Engineering, Baramati. Today's my topic is structural health monitoring application theory. So before we are going to take this one, you need to what are the factors, what are the various factor which is leading to the that is what you say, that is degradation of the material, and why the structural health monitoring, that is SHM, is required. The first factor which is very it is degrading the material is corrosion, that is corrosion of conventional steel within the concrete. As you know, if there is a corrosion in the bar, then it will be the area of that bar will be expand, or because of that expansion you can see there is a degradation of the material, because the steel strength if goes down, then the structure will be, the integrity of that structure will be fail, and the strength will be automatically less. Then what are the consequences? That is already I told, that is expansion of steel lead to cracking and spalling, future and further deterioration of the structure is achieved. Then result reduction in strength and serviceability, resulting in need of repair and replacement. So this is main of one factor which is mostly affect the structure. Then second factor is that is increased load. Okay, increase load or design requirement over the time. Suppose we plan for a, suppose there is a building or some other structure. Suppose the structure load, that suppose we are planning before some 25-30 years ago, we are planning with some design load. If this load increases, then there is a deterioration of the structure and the degradation of the structure. If the load increases, then increased deterioration due to overload and structural inadequacy resulting from the design. Then result or consequences is that structure deemed unsafe or unserviceable, and strengthening of replacement is required. Then third factor, which is overall deterioration and or aging. Due to aging, the structure is deteriorated, and then what are the consequences of that deterioration? That is various detrimental effect on structural performance, both safety and survivability is measured. Then what are the consequences? What are the result? Need of repair, rehabilitation, strengthening or replacement. So what we see in these above three factors, then it is totally depend that the structure is degraded due to these factors. These basically these three factors. It may be other factors also, but the main causes of that factor is like that. Then why replace with same material and methodology? That is, this is structural health monitoring. That structural health monitoring. What is structural health monitoring? I will going to tell you what are the advantages. What is the structural health monitoring? We can replace these structural failures. That is strengthening of material. Suppose if you see, if you going to construction of a new building, yeah, new structure, then there is a huge amount of money is required. If you remember, all the participants have remember, there is a bridge collapse in Mumbai area, and some of lives, important lives are it is loss due to that area. We can monitoring such, and in India there is a lot of bridge, but that bridge, lot of bridge and structures having deteriorated due to these factors, these above three factors, and we can minimize that collapse using various structural health monitoring techniques. This is the main cause of the structural health monitoring, and this is the main focus of that this session. Then if you are going to see, above three factors are very common to all type of damages or deterioration of the structure. We can replace this using some methodology. First one is structural health monitoring, and later on, if you going to use some advanced materials like FRP, just not FRP, there are a lot of materials there. You can minimize these types of failures. The new and innovative material and monitoring tools that prolong the service life of structure with decreasing cost. Suppose right now, if you are doing some structural audit, and when we are going to audit some structures, then we can see at that time that the structure life is only 20 to 25 years. While we are designing more than that, but the structure is now in damaged condition, a degradable condition, because of n number of reasons, not these three numbers, and we can see the structure is failed, and we cannot do anything, and you demolish the structure. And at that time, what are the basic cost of that structure? What are the expenditure of that structure we cannot get from that service life. Then to avoid this kind of things, we can prolong the service life of the structure, which decreasing the cost. In structural health monitoring and with modern material, we can prolong the service life. This is the one main important factor. And another one is decreasing cost. Suppose we are going to construct one whole structure, then it will be depend upon that structure, it will be the cost is more. And if you are going to strengthen the structure, the cost may be less. Okay, so here what is the structural health monitoring? What is structural health monitoring? This is structural health monitoring is nothing but we just learned that SHM is a process of ascertaining the level of damage in part of structure during its life period. Suppose we have constructed one building. Suppose we are constructing flyover. If you are going to monitor this structure, health monitoring. Suppose right now a lot of health issues is there. जैसे हम क्या करते हैं कि हम टाइम टू periodically we can test our health conditions. Same way we can do for the structural health. Why we are assessing that health? Because our main focus is prolong the service life and decreasing the cost of that construction. And main focus is that we are going to see what are the losses, that is life, important lives there will be to save. And it is not only the prolong the lives and decreasing the cost, it is also, suppose there is a failure, then we can advancedly we can check Okay, what are the condition of the structure, and you can stop using that structure or any type of that, and you can save the lives. This is the first, that is we need to, during the life of structure, with assessing the structure life. Then aim is to assure structural integrity, periodic inspection to detect damage resulting from fatigue, corrosion, excessive load, impact, etc. We can restrict the use. Suppose I am going to check the integrity of the structure, and when during the what you say, during the during the structural health monitoring, if you see there is a structure and the less what you say, there is a danger sign is we are getting from that structural health monitoring, then you can avoid to use this structure. And after that what you say, that strengthening your all these thing remedies, then you can use. Then structural health monitoring using smart material is one of the best possible solution. There is a lot of way we do the structural health monitoring. Previously we have a lot of traditional methods, and traditional method we do the structural health monitoring. There is a lot of advanced materials which is going to used in the structural health monitoring technique. I will going to look on that matter. Okay, then structural health monitoring using smart material is one of the best possible solution. Then smart material involves piezo electric materials, optic fiber, same memory alloy, etc. These are the modern materials which are going to used in the smart material. But in this topic, we are going to use the piezoelectric material, that is PJT patches for structural health monitoring. Yes, sir. The slide is not changing anything. But sir, there is any problem if the slides are not changed?
No issue, sir. हो गए, चेंज हो गए.
ओके, एक मिनट. हाँ,
Okay.
नहीं हो रहा शायद. Okay, then what is SHM? That is, SHM is nothing but is agenda in service performance of the structure using a variety of measurement techniques, and these techniques are nothing but leading to smart structures. And if you see, there is a firstly that Taylor bridge, that is Taylor bridge, that in that bridge, first there is a number of sensors are embedded in that bridge, and there are this is the first time in that what you said, this is first smart structure. Okay, why the SHM becomes so popular? That is, first one is increasing need of monitoring of innovative design and materials. This is first thing that structural health monitoring is more emerging to use of that innovative material. Second one is better management of existing structure, as we already discussed. Suppose we are going to monitor, then we can existing structure का better management हम कर सकते हैं. The second one is the ongoing development of new sensors. That you can see there are a lot of sensors are available, and it will be smartly it can be done, that one. Then another one is data acquisition system. Now there is a lot of data acquisition systems are available. As AI is developed so much, then it will be more useful. Wireless and internet techniques, and we can do in wireless and internet technique. That's why it is the SHM technique. SSM is very popular nowadays. Then data transmission, collection, and archiving, and all the receiving all the data. That's why the structural health monitoring is more popular by these days. Data processing and event identifications. Okay, then sir, actually there is problem. I cannot change my slides. Kate sir?
Yes, sir. No, there is no problem. Please continue.
Then in my side, the slides are not changing.
What happens?
It is here, it is changing, but when we go to the full screen mode, and it is
Okay.
quite, it is difficult to change, I think.
If there is PDF available,
I will do that. And I will
yes.
save as into the PDF.
Then please continue.
Just 1 minute. Sorry for
Yes.
inconvenience.
Yes, yes.
एक्चुअली पीडीएफ करने के बाद शायद वो डेटा जो इफेक्ट है ना वो नहीं आएगा, मुझे लगता है। ठीक है,
No, no. I think it was seen. Please.
इट विल बी, मतलब मैंने जो किया था वो नहीं आएगा। ऑल्सो ओके, बेटर अगर वो नहीं रहा तो बेटर ये वाइज ठीक करेंगे।
Yes, yes. Please continue.
Then structural health, I will try one more time. If
Okay.
it's fine, okay, I will try one more time. It is not, then I will do that. Okay, so what is structural health monitoring? Now it is working. Okay, so there are two types, as we discussed previously. There are two types of structural health monitoring system is there. That is, one is non-destructive structural evaluations and the use of several types. Second one is use of several types of sensor embedded or in attached to a structure. There is basically two types of structural system is there. What non-destructive means, this is the traditional methods, okay, where in NDT method, Raymond hammer test, ultrasonic test, these are the tests which are used traditionally before development of smart materials. Our topic is smart material, but that non-destructive evaluation, that is NDT, ultrasonic and all these things, and carbonation test, ये सारे जो है वो previously we are used these types of techniques. But recently we are going to take in that sensor technology to use for the structural health monitoring. That is, both are structure safety, strength and integrity of performance, but that traditional method is so not effective, but it will be always आपने को side में जाना पड़ेगा उसको करने के लिए. But when we are going to put the embedded systems and the wireless network system, we can monitor the structure where, मतलब suppose अपने ऑफिस से भी हम उसको monitor कर सकते हैं. तो what is this structural health monitoring? If you see what is the structural health monitoring technique is that if you consider medical doctor and if you consider a medical doctor and if you go for a engineer having structural health monitoring, then you can see in medical doctor first monitor the patient health. Okay, use of medicine, use of medical equipment to check the overall health, and the third one is prescribe corrective medicine if required. This is the total use of that SHM. That is, medical doctor can assess one of the condition of a patient. At the same time, if there is a structural health monitoring engineer, then they can use, that is, monitor condition of the structure, use sensor to check the overall structural health, and if excessive stress or deformation is required, then correct situation they can apply that medication, jo all these things, and they can, excessive stress or deformation is find out, then they can go for the structural health monitoring and these systems. So what are the structural health monitoring components? So before we are going to see the what are the structural health monitoring components, we are just going to watch one video, that is, which is related to the structural health monitoring and which how the structural and why the structural monitoring will be going to see. Then I will just so that in YouTube these are available. You can, when there are a lot of structural health monitoring video is available. Just I am this is one of the monitoring method. I am find out when I am working on that field. Just we are going to watch this one.
There are many uses for these electrical devices in today's vehicles. We see their effects without a second glance. Hi, I'm Clint, and welcome to Automate. There are many uses for these electrical devices in today's vehicles. We see their effects without a second thought. So you think if you diagnose a fault for one of these, I'll help you to whisper. Here's why I'll never go back.
Okay, sir. Now my video is running. Kate sir. Hello, Kate sir. My
Yes, sir. Yes, sir.
Yes, sir.
screen is visible.
Yes, sir.
Okay. Okay.
Structural health monitoring, SHM, is the procedure of monitoring
Please continue.
the geometric and material qualities of civil engineering structures like buildings and bridges over a period of time using sporadically sampled measurements. The results of this procedure for long-term SHM have frequently updated information about the structure's ability to execute its envisioned function in light of the foreseeable age and degradation caused by operational settings. SHM is utilized for quick condition screening after life-threatening events such as earthquakes or landslides, and it seeks to offer trustworthy information on the structure's integrity in near real time. The objective of structural health monitoring. An existing structure's performance can be improved. Following are the important conclusions that can be drawn from structural health monitoring. Monitoring of structures impacted by external influences. Response loop to enhance forthcoming design model based on experience. Evaluation of structural integrity after the earthquake. The decline in construction and increase in maintenance requirements. Need of structural health monitoring. Observing a structure on a regular basis may help to extend its life and improve its performance. The appropriate maintenance can be determined through continual observation be carried out in order to extend the structure's life, and following it, there was a complete failure. SHM aids in the decision-making process. Current structure status or damage to the structure, if any, and, as a result, any form of maintenance decided. Any country's economy is based on bridges, railways, and roadways are examples of infrastructure, etc. Any breakdown of these infrastructures on a structural level might be disastrous. In the case of a country like India, there are numerous bridges that were built decades ago and are still in service. These bridges are now carrying heavier loads. Failure of these facilities could have a negative impact on the country's GDP. As a result, it is critical that these bridges be monitored regularly using suitable health monitoring techniques. A sudden failure of any infrastructure could result in a catastrophic event, resulting in a loss of serviceability or access. The building is also vulnerable to a variety of natural phenomena that could cause harm. If structures are monitored continuously or on a regular basis, the behavior of the structure can be better understood. If the damage is discovered before the structure fails, adequate actions can be done to prevent the structure from falling. The economic growth of a country is harmed when a bridge or other tall structure collapses. Every structure is built to last a specific amount of time, and it is thought that it will continue to serve its purpose throughout that time. What is the procedure of structural health monitoring? Following are the steps or processes of structural health monitoring. Determination of damage existence. Determination of damage's geometric location. Quantification of damage severity. Estimate of the remaining life of the civil engineering structure. What are the well-known structural health monitoring devices? Collecting precise and high-quality real-time measurements of structural element status, sharing this information with the control system, and signaling appropriate alerts if an unusual pattern is ever noticed are all critical components of structural health monitoring. Sensors for structural health monitoring are designed to make the monitoring process easier while also providing maintenance engineers with decision-making tools to ensure the facilities and the public safety. A typical health monitoring system consists of a network of sensors that measure stress, strain, vibration, tilt, humidity, and temperature, among other characteristics important to the current state of the structure and its surrounding environment. Fiber optic sensors. In recent years, fiber optic sensors have seen a lot of progress. These sensors can be used to measure a variety of factors in civil engineering. Strains, structural displacements, vibration frequencies, acceleration, pressure, temperature, and humidity are only a few examples. The local approach focuses on material behavior, whereas the global approach is responsible for monitoring overall structural performance. Fiber optic sensors have been investigated for a variety of applications, including strain monitoring of concrete bridge components. Accelerometer for structural health monitoring. An accelerometer is an electromechanical device that assesses acceleration forces in single or multiple axes. Such forces can be static, such as the constant pull of gravity on structural components, or dynamic, such as when a truck crosses a bridge, to detect motions or vibrations. Accelerometers are used in a variety of applications, from smartphones to spinning machinery and civil infrastructure. Accelerometers can be utilized for real-time evaluation of structural dynamic features due to impact or changes in structural performance. Accelerometers with several axes are primarily used to identify the magnitude and direction of correct acceleration. Accelerometers are also widely used in structures where the dynamic performance of the structure must be controlled in the short as well as in long term, as had 2018. What is static field testing in structural health monitoring? The static studies goals are to limit maximum strains and stresses, detect cracking in the structure, record strain variations during construction, testing, and in the next 10 years and compare traditional and fiber optic systems. What is remote structural health monitoring? Latest advancements in low-cost remote monitoring systems have made large-scale structural health monitoring, SHM, conceivable and realistic. Due to the degree of specialization necessary, it is hard for a single remote monitoring system to handle a wide range of SHM applications. This article introduces Duramote, a new economical, advanced remote monitoring system that can aid as a next-generation supervisory control and data acquisition (SCADA) system for civil engineering infrastructure systems, in order to make the remote monitoring system more flexible, maintainable, and robust. What are the advantages and limitations of structural health monitoring? The current setup of structural health monitoring provides a safer option in which damage may be detected and repaired rapidly. One of the drawbacks has been the cost of the equipment, as well as the ongoing upkeep. Recent work in future scope in SHM. A monitoring system is made up of a number of sensors that track the environment, as well as the structural response to stresses. Remote sensors are attached to a centralized monitoring system in a conventional monitoring system. As a result, putting out more effort to develop appropriate data processing algorithms is currently necessary.
लड़कियों से लड़की क्या मांग रहे हैं जो दे रहे हैं उस पर ध्यान दे ले ये बोतलें
Just what you see here right now, this is all about that is structural health monitoring, and some part of the videos are go to that advanced sensing technology and that smart material which are going to use in that structural health monitoring. That is in structural health monitoring system. If you see here, what are the components of structural health monitoring? This is the acquisition of data. You need to allow the data acquires the data, then the communication of data, intelligent processing, storage of process of data, then finding out the data and what are the diagnosis of that data is there. Okay. Then what are the SHM category? What are the structural health monitoring category? Already in that video we have seen that there are 4 types of categories is there. That is static field testing, dynamic field testing, and periodic monitoring and continuous monitoring. These are the 4 SHM category. That is static field testing means this is nothing but it is the traditional methods we are going to use the data somewhere interval something like that. Then dynamic in dynamic field testing, that is stress history data, these are we are going to find out. Periodic monitoring including field testing, also these are the some NDT methods which are old methods. Now another one is continuous monitoring, that is active monitoring and passive monitoring. In continuous monitoring, we can use the advanced materials and sensors for using the structural health monitoring. Then what are the level classification of structural health monitoring system? Then first level is detect presence of damage. In structural health monitoring, we are going to see the what are the level. First level is that is we need to find out, detect the presence of damage in first level. In second level, what are the structural health monitoring system is detect presence and location of damage. First level, we can find out the presence of damage, and second, we can find out the detect the presence and location of damage. In third level, we are going to detect the presence, location and severity of damage. And in third stage, we are going to do the both three, that is detect, location and severity. And in fourth stage, we are going to see the consequences of damage. So these all 4 are the structural health monitoring system. If you see, this is our structural health monitoring, that is increase what are the consequences of the damage. When we are going to from level 1 to level 4, the consequences of the damage is increasing. And when we find out that increasing in the consequences, then we go for the structural health monitoring or repair. What are the advantages of structural health monitoring? That is increased understanding of institutive structural behavior, early damage detection, assurance of the structural strength and serviceability, decreased downtime for inspection and repair. This is the more important. When you are going to structural health monitoring, the repair and inspection time will be less. Development of rational maintenance management strategy before failure of the structure, increase effectiveness in allocation of scarce resources, then enable and encourage use of new and innovative materials. What are the innovative materials? We are going to study later on what are the innovative material used in the structural health monitoring system. Then that methodology, that is information and demand about the structural health. Then warning regarding any damage detected, and these are development of SHM system involves utilizing information for many different engineering discipline. Okay, these are the structural health monitoring methodology, and in that you can see here that all the disciplines are included. Not only civil engineering aspect is there, you can see we need computer engineering, we need communication, we can sensor technology, we can data collection, and all AI technique whichever right now in the focus of pura worldwide jo focus hai, that is AI technology. You can use this AI technology and you can monitoring the structure by using this advanced structural health monitoring systems. Then what are the components? You just see here. This is one the component you can find out. Suppose this one is the there is a bridge. There is a bridge, that is the monitoring structure. If you here, then we place the sensors here. Before we are going to see the all these types of sensor, how will you going to it is work? I will just put one video that what are the sensor, PJT sensor, and what types of sensor it is and how it is work. I'll show this in this video. You can clarify what are the PJT, because it is if you are in civil engineering domain, then you can maybe some people are not understand about what are the sensors. तो मैं उससे पहले आपको दिखाना चाहता हूं कि जो हमारा मेन फोकस है, दैट इज स्ट्रक्चरल हेल्थ मॉनिटरिंग यूजिंग स्मार्ट मटेरियल्स. And in this, if you see here, that is there is a lot of smart materials just like fiber optic cables, PJT sensor. My presentation part is PJT sensor, that is piezoelectrical sensor, and how this piezoelectric sensor used for the civil engineering structure to detect the damage and structural health monitoring. Just see this video, then we will continue further.
Hi, I'm Clint, and welcome to Automate. There are many uses for piezoelectrical devices in today's vehicles. We see their effects without a second thought. We can diagnose a fault in one of these, not knowing how they work. Let's take a closer look at piezoelectricity. A knock sensor is a piezoelectric vibration sensor. When engine detonation occurs, the vibrations are transmitted through the engine block to the sensor body. Inside the sensor vibrations from the detonation create pressure on the ceramic that is proportional to the knock. The ceramic generates a voltage based on this pressure and is signaled to the ECM for conversion and interpretation. With a scope attached to the sensor, any substantial vibrations will be detected and reflected as an alternating current signal. These sensors are signal generators, and as such, they don't require a reference voltage to operate. The main reason for using piezo technology is because of its accuracy and reliability. This air conditioning pressure sensor, we're able to read very small changes in refrigerant pressure by amplifying the signal. This is a sample of the hundreds of training videos we have available, covering everything from technical fundamentals, diagnostic procedures, equipment, and wiring diagrams. Automate is simply the best training available. So why not join us today? Start training and be the best technician you can be.
Okay, then we can see here, this is one of the piezoelectrical sensor.
This is the complete setup for the experiment, which includes donde the important enhanced corpus आणि त्याच्यासोबत लाखो रुपयाची lifetime guarantee पण ती दोन्ही मिळू शकतात. एवढंच काम करायचं मार्केटिंग पेन्शन प्लॅन आहे ज्यामध्ये तुम्ही 2005
Okay, so this is one of the topical view of that sensor technology. I am going to tell that there are the various types of sensor. You just right now you are just watch that video which is used. It is called as piezoelectric sensors, and these piezoelectric sensors are acting as a actuator and vibrator also. And when we are going to see how the components are working. Okay, so this is one of the sensor. This is the topical diagram of a bridge, that is monitor structure. Here the red dots are the sensors that they are attached, and the that is the communication system. And this is total after receiving the data. This is the data storage and decision making, and we can find out what are the data we are analyzing, and then we are going to see the data. This is the one of the you can diagrammatic view of that. What are the component of sensor technology, or we can follow for the structural health monitoring. Then what are the acquisition of data? That acquisition of data is nothing but for collecting the raw data from monitoring structure. Then selection of sensor, how we are going to acquisition of that data. Then we need to first find out the selection of the appropriate sensors. Then long term and short term monitoring. Then what aspect of the structure will be monitored, and sensor must be serve intent function of the requirement duration. Then sensor installation and placement, and how we are going to in methodology, how are we going to find out or going to install that sensor. Must be able to install sensor with alternate the behavior of the structure. The structure behavior will not going to affect during that structure. There are two types of we can apply the sensor to the structure. First one is surface bonded, or another in inbuilt. When suppose there is a structure all during construction, you can inbuilt that a sensor into that structure, or we can surface bond of that structure. Just I'm going to play another videos which is that experiment is done in IIT Delhi, and that video also we are going to play. And I am also doing a lot of work in that direction. I will going to, when our practical session is there, I am going to do that. Then next is features such as sensor wiring, conduit junction boxes, etc. Then these are the installation of placement. Then in acquisition of data, that is transfer of the data. That data should be transfer from one point to that point. That figure, which that figure is said in that schematic view, we can see that how this data we are going to transfer. Though these are the dash, that is transfer of data acquisition systems. Then wireless transmission, second one is. Then data sampling and collection. The amount of data should be not be so more, that should be, it should be limited, that issue. Okay, then result, that sampling of data and collection should be done as per whatever the data we received, and this sampling will going to minimize as we can take that data as per the some interval is there. Then sample data acquisition algorithm, what type of data we are going to record, what type of the data we are going to record. That is suppose you see here, record only value greater than the threshold value. Suppose there is a vibration in that these are the threshold value, and these are the frequency of that vibration. Suppose after this threshold value we can acquire this data. And after, suppose there is a suppose I am going to, how the piezoelectrical sensor is working. When you are going to take put the pressure on that, then at that time, suppose we are put that pressure, then the vibration, suppose there is a regular monitoring is there, so this data would not to be taken. We can take, this is on the threshold value. Then after that we can, after that threshold value we can take. Then these are the record only the significant changes in the recording. Then these are the acquisition of data. Then what is monitored, and how and why. That is load, the magnitude and configuration of forces applied to the structure. Are they are how they are? Hello?
Please continue, sir.
I think someone asking some question.
Yes, yes. No. I think interrupt.
My screen is visible, sir, because I'm seeing
Yes,
there
sir.
is line
Yes,
in
sir.
the
Yes.
screen.
Please continue.
Okay, so first, what is monitored, how and why. The first one, we need to monitor the load, magnitude and configuration of the forces that apply to the structure. Suppose how this data we are going to monitor in that monitoring system. Then a deformation. First one is load and second one is deformation. You need to one, and third one is strain. Strain we are going to monitor in that strain gauge using that sensor. Then temperature, you can also check the temperature using, there is a thermal expansion sensor is there. We can use that temperature for that also. Then acceleration also we can, frequency versus acceleration we can find out. Then wind speed and pressure, this data we can find out from the sensors. Then there is acoustic emission is there, video monitoring also there. So this part we can do in that. Then what are the communications? These are the communications. These are when that setup is generated, then these communication also we can find out using this telephone, internet and wireless. Okay. Then what are the data? Now after that, the data we can process using the various data process. जैसे एक MATLAB हो सकता है. There is more things that we can process the data also. Then storage and process the data. Why I am just brief one, because this is not उसके पहले हमारे जो experiments है उसके ऊपर focus करना है. That's why I am processing, storing the data. Latter part I am going to tell the latter next is. Then diagnosis क्या करना है, that is that what are the diagnosis we are going to do, that also we can that methodology used to depend upon the type of structure, type and location of the sensor are used. Then data, we can find out the significance of data, confidence in analysis. These are I think this one is these are the structural health monitoring and the methodology. In that methodology, what we see that we should monitor the structure, then data acquisition the system, then system, what are the diagnosis we are going to tell. वो सारे चीज जो है मैंने आपको डायग्राम में बताया था और उसका एक्सप्लेनेशन था कि क्या क्या डेटा हमको लेना है. बट उससे पहले हमको व्हाट आर द सेंसर टेक्नोलॉजी, वो आपने को देखना जरूरी है, जो मैं आप लोगों को सेंसर टेक्नोलॉजी के बारे में ऑलरेडी बताया है. तो दिस इज व्हाट यू सी, the many sensor types are currently available. That is choice of SHM depends on various factors. That is fiber optic sensors. These are the some fiber optic sensor we are going to do. Then sensor development driving advance in SHM. That is already we are seeing some examples. Then advantages, that is stability, non-conductive. So these are the sensor technology, how it is work. Then now we are going to, after seeing that all sensor technology and what are the data acquisition system, now we are going to see what are the various types of work we are doing in the civil engineering field. This is one of the nice video prepared by Dr. Bhalla sir, IIT Delhi. Just see how these sensors are working.
This is the complete setup for the experiment, which includes a function generator, amplifier, oscilloscope, and a shaker.
Unable to see video, sir.
Now, if we take a closer look,
Mike, sir.
Yes, sir.
There is video is not seen. I think please again view your presentation and again please start.
So now it is visible.
Yes, sir. Yes, sir. Visible. Please continue.
This is which is inside the concrete beam. These are the out of the sensor. This one is for the top sensor and this one is for the bottom sensor. I've given a notch at the 1/3. This one
Okay,
is for the bottom
when
sensor.
the madam,
These
core
are the
madam is
connectors
explaining,
coming out.
at that time you just see these are the surface embedded sensors which are already inbuilt in that during construction process.
Of the sensor. This one is for the top sensor and this one is for the bottom sensor. I've given a notch at the 1/3 length of the beam. This is to create a damage condition. We will be creating 3 levels of damage in which first level will be chipping off the concrete. In the second level, we will curtail the 50% of the reinforcement and in the third level, we will curtail 100% reinforcement. This is an inertial type shaker developed in our lab. It has been transformed from a contact type shaker. The benefit of this inertial type shaker is that we can enhance the force transmitted to the beam, which was earlier 98 newtons in case of contact type shaker and 108 newtons in the inertial type shaker. Now, the principle on which this shaker is working is that the vibration of this inertial mass, which is the plate in this case, is transferred to the beam by these 4 springs. The additional mass can be increased or decreased by adding or removing these extra plates developed for additional masses. This is the function generator and this is an amplifier. This function generator gives an electrical signal which is amplified by this amplifier and then further transferred to the shaker, which gets converted into mechanical signal. Now, before starting this amplifier, some signal should be given to it. We will switch on the function generator, give a noise signal here and switch on the output. Now we will start this amplifier. As soon as we see a number 1920 here, we will press this button. Now it's ready to use. Next step is to give us sine wave in this function generator. For that, we will switch off the output. These are the different type of electrical signals which can be given using this function generator. We will give a sine wave. So we will give a 10 volts peak to peak voltage and a frequency of 16 hertz. Now if we press a button graph, we can see the sine wave generated by this function generator. Amplitude of plus minus 5 volts and a frequency of 16 hertz. Switch on this output and slowly increase the gain. Make sure this number doesn't go beyond 2. If you connect any of this sensor with the oscilloscope, we can see a sine wave signal when I switch on the output, which dies down as soon as I switch off the output. Next step is to measure the energy or power generated. For this, we have fabricated a circuit in our lab. Since the current is very small in the sensor, so it's very difficult to measure. So we have fabricated this circuit using which we will cross the resistor R1 and then calculating the current. Here we set the and here output resistor R1 is also. Let me switch on the output. This is the voltage signal which is
Okay, so these are the some how we are going to use using that sensors technology that we can find out uh, and how the embedded system is there to find out this one. Just before to that, these are the some sensors. That is, I think we have already seen what are the PJT sensors. This is just look here. These are the some sensors that these typically this is one of the PJT sensor, and this sensor use as a actuator and vibrator. When this sensor we are connecting to the digital oscilloscope, then it will be the electrical signals which is transmitted, and it is converted to mechanical signals. Now then these are the some theoretical part which are we are sees how the structural health monitoring is done using various sensors. In our next session, या in next session we are going to see the applications. मैंने इसमें आप लोगों को applications नहीं बताया है ऑलरेडी, ओनली हमने क्या किया है कि इसमें स्ट्रक्चरल हेल्थ मॉनिटरिंग कैसे हो सकता है और स्ट्रक्चरल सेंसर्स कैसे यूज करना है, वो चीज मैंने आज के जो भी मेरे लेक्चर था उसमें बताया कि व्हाट आर द टेक्निक्स ऑफ स्ट्रक्चरल हेल्थ मॉनिटरिंग. Later on when in our next lecture, yeah, next lecture we are going to see the how these PJT patches we are going to use in various types of structure. This is one of the example of bridge. We are making this bridge in our lab, and here these are the three patches we are put in the that structure, and we have vibrated this structure, and after vibration how this structure after vibration we are conducted that experiment, and how this data we are transmitted in our second lecture. I will going to explain how these models are working or what are the analysis and all these things is available in this one. So this is totally one of the introductory part of structural health monitoring using PJT patches. The applications and all this we are going to see in our next next lecture. Kate sir, any doubt from the audience? Then you can see.
Yes, sir. Yes, sir. I think there is a very wonderful session. Hello.
Yes, sir. Continue.
So please ask anybody from audience.
Today, actually, there are a lot of applications in this using various smart techniques. There is a lot of application to the civil engineering society. Just you just I'm deliberately just put this figure here. That is that AI system and data transformation, piezoelectrical energy harvesting. जो कौर मैडम अभी बता रहे थे उसमें एनर्जी हार्वेस्टिंग का मैंने जानबूझ के स्टॉप कर दिया है वीडियो. ऐसे बहुत सारे चीज है जो हम उसके एप्लीकेशंस एंड प्रिंसिपल्स देखेंगे नेक्स्ट प्रैक्टिकल में. वी आर used these practical applications to concrete cube, timber, bridge. Then right now we have filed a patent, design patent using AI technology for energy harvesting. And I am happy to share that today that design patent is granted by Indian government. That is, if you see here, my some of the my students, these students and me filed that patent before, design patent before I think it is in November month, and this design patent is today granted. And this you can just see here, application is accepted and certificate of design not generated. And this is all about that what you say, this is AI system, that energy harvesting, and there is a lot of scope. And now recently all the technologies are going to in AI direction. So it is one of the most good area, emerging area to convert all this part to do in that is AI mode using various types of sensor and all these things. You can see these sensors are also used for biomedical के लिए भी use किया है. If you go to Dr. Bhalla sir, I think Bhalla sir session is on Friday. Friday. This is actually I am following Bhalla sir, and
Yeah,
we are
yeah.
also taking lot of time to Bhalla sir, and there are a lot of scope in this topic, that is sensor technology, and it is used in the civil engineering domain. Yes sir, any question? Can you we can take their questions.
Hello.
Yes.
Good evening, sir. This is Dr. Manisha Wagmare from
Yes.
AISSMS College of Engineering.
Yes, ma'am.
Very nice session, sir.
Thank
You
you.
have introduced few practical approaches also. I would just like to know whether you have the facility of giving time history to the check table in your college. Do you have the
Actually,
facility?
madam, we have SEC table is not here in my college, but we are applied the time history data. We are not applied till date. We are applying all these to just manually or some motor generated. That is the data set. We are not applied till date because we
Okay, so
have not.
sine wave is applied.
Only sine wave data applied, and suppose some time we have manually also applied that load, not by manually in the sense there is some rotating hammer. This is free from that some height, and then you can measure that. But data set till date we are not applied.
Okay, sir. And which data acquisition system you are using, sir?
DSO, digital oscilloscope, we are used. LCR meter also we have used for that.
Okay. Okay, sir. Thank you, sir. And what is the capacity of the shake table? Because if some experimentation is planned.
मैडम सेक टेबल मैं मेरे इसमें सेक टेबल नहीं यूज किया है.
Okay.
मैंने क्या किया है कि एक जो अपने मोटर है, मोटर का कैपेसिटी के हिसाब से उसको वाइब्रेशन दिया था. देयर इज नॉट सपोज इतना डेटा सेट देना है, वो नहीं किया है मैंने उसको क्या किया है, जैसे आपने को अभी वो कौर मैडम ने एक जो वीडियो चालू था बीम के
Yes, sir.
ऊपर, उन्होंने जैसे
हाँ.
वो जनरेटर रख के वाइब्रेट किए थे,
हाँ, बीम को
ऐसे हमने
वाइब्रेट किया.
वाइब्रेट किए थे. पर्टिकुलरली इतना डेटा सेट के लिए नहीं अप्लाई किया.
Okay, okay. Sir, thank you, sir.
Thank you.
Some papers must be available on this experimentation.
What, madam?
Papers are available on this
Yes.
experimentation?
Paper also we have already. I am 5 to 6 paper is there for this journal paper, Scopus and ACI index paper is there, and 2 patent and 2 Atal FDP and 1 research grant from SPPU. And we have in this field I am when I am applied these types of for funding and all this we are getting from this various organizations.
Congratulations, sir. Thank you, sir.
Thank you.
I think one workshop also attended, no, sir, from
There
DST.
are 2 Atal FDP, 1 SCRB, and 4 paper I think Springer paper, and 1 design patent जो आज ग्रांट हुआ है. ऑलरेडी वी हैव नॉट प्लान फॉर द पेटेंट, और पेटेंट नवंबर महीने में डाले थे हमने, तो आज 2 महीने भी नहीं हुआ, डिजाइन पेटेंट हमारा ग्रांट हो गया है. तो आई थिंक वी आर गोइंग टू पेटेंट उसके हिसाब से, और एक अपने को ये पेटेंट करना है, कमर्शियलाइजेशन के लिए पेटेंट करना है, बट यूजिंग भल्ला सर के हिसाब से करना है, क्योंकि वो मेंटर है उस डायरेक्शन में, उनका और मेरा होता है. उनके वेबसाइट में आपको उस दिन ही दिखाने वाला था, या सर ही दिखाएंगे आप लोगों को. उनके जो वेबसाइट है, अगर आप आईआईटी दिल्ली में जाएंगे तो उनका एक पूरा वहाँ पे सब कुछ है. तो ही इज डॉक्टर सुरेश भल्ला, और ये बहुत मतलब इसके ऊपर उनको देख के हमने सीखा है सारी चीज. आप अगर आईआईटी दिल्ली में लैब में जाएंगे, स्मार्ट स्ट्रक्चर एंड डायनामिक लैबोरेटरी, यू कैन गेट ऑल द वीडियोस एंड कैसे करना है, क्या करना है, सब कुछ उसमें है. लॉट ऑफ वर्क वो कर रहे हो. उनके वहाँ पे एक सोसाइटी भी उन्होंने डेवलप किया है, अभी लैब भी किया है. आप जस्ट गूगल में आईआईटी डॉक्टर सुरेश भल्ला अगर आप डालेंगे तो आपको वहाँ पे बहुत सारे इंफॉर्मेशन उनके लैब के ऊपर मिलेगा. तो वहां पे आप देख सकते हैं ये पूरा लैब है उनका। मेरा
Yes.
स्क्रीन अवेलेबल है सर?
नहीं सर, आपने शेयरिंग बंद किया है शायद, प्लीज
ओके,
चालू।
जस्ट 1 minute सर, आई विल जस्ट शेयर माय स्क्रीन। सॉरी, ये देखिए दिस मतलब इनके अभी दिख रहा है सर?
Yes, it's
देखिए,
visible.
अगर आप इनको फॉलो, अभी मुझे लगता है इनका फ्राइडे को लेक्चर है और
Yes, sir.
वो सेंसर के ऊपर नहीं, काउ डंग के ऊपर बता रहे, बराबर है। तो इन्होंने देखिए इधर एनर्जी काउ डंग करके उन्होंने किया है। तो एनर्जी हार्वेस्टिंग, अभी जो मेरा रिसेंट पेटेंट हुआ है उसमें एनर्जी हार्वेस्टिंग का किया है हमने, मतलब
Right.
रोड से सेंसर यूज करके कैसे हम एनर्जी हार्वेस्ट कर सकते हैं, तो उसके ऊपर हमारा वो पेटेंट अभी डिजाइन पेटेंट हुआ है। और आई एम फॉलोइंग भल्ला सर फ्रॉम 2012, और उसके ऊपर से 2-3 पीएचडी स्टूडेंट और 10-12 एमई के स्टूडेंट भी पास आउट हो चुके हैं। पेपर भी
Yes.
है, बहुत इमर्जिंग एरिया है, बट बहुत कुछ सीखना है उसके ऊपर। जैसे मैडम ने बोले कि सेक टेबल के ऊपर डेटा सेट यूज करना है, तो हमारे पास सेक टेबल नहीं है, तो वी आर ट्राइंग टू अदर वे टू पास दैट, क्रिएट सम, मतलब वी कैन टेक सम, व्हाट यू से, एक्सपेरिमेंट्स, यू कैन मेक सम एक्सपेरिमेंट्स फ्रॉम अदर। तो उसके लिए हम ट्राई कर रहे हैं उसके लिए।
Yes, yes. Very congratulations,
Very
sir.
nice work, sir.
थैंक यू।
Yes, sir.
Yes, good, sir.
तो मेरा ऐसा कहना था कि आपने जो ACRB का जो वर्कशॉप किया था,
हाँ हाँ,
उसमें पीजीटी मटेरियल्स और कुछ ऐसा ही रिलेवेंट
स्मार्ट
टॉपिक।
मटेरियल सर, ऑल आर पीजेटी स्मार्ट मटेरियल्स।
हाँ
So
हाँ।
PJT smart material, that is piezoelectric material. This is called as PJT. तो उसको
Yes.
शॉर्ट फॉर्म में हम PJT बोलते हैं, that is piezoelectric material.
Yes, yes. Piezoelectric.
हाँ,
I think there is a testing was done on one bridge.
यस यस यस। अब
Extensive.
मैं अभी जो मेरा एप्लीकेशन पार्ट रहेगा नेक्स्ट इसमें, तो मैं उसमें वो पार्ट एनर्जी हार्वेस्टिंग और एप्लीकेशन टू पीजेटी जो हमने सिविल स्ट्रक्चर के लिए किया है, मैं नेक्स्ट इसमें वो बताऊंगा। इसलिए मैंने वो मैडम का जो वीडियो चालू था एनर्जी हार्वेस्टिंग का, कौन सी एक और मैडम का यहाँ से एनर्जी हार्वेस्टिंग जो चालू हो गया, तो एनर्जी हार्वेस्टिंग इसीलिए मैंने स्टॉप कर दिया, क्योंकि हमको पहले एनर्जी एप्लीकेशंस देखना है कि हाउ वी
Yes.
आर गोइंग टू अप्लाई दिस पीजेटी पैचेस टू अदर स्ट्रक्चर्स, एंड हाउ विल गोइंग टू मॉनिटर फर्स्ट, एंड आफ्टर मॉनिटरिंग हाउ विल गोइंग टू हार्वेस्ट दैट एनर्जी।
Yes.
हाँ, और मेरा जो पेटेंट अभी हुआ है वो एनर्जी हार्वेस्टिंग के ऊपर हुआ है। हमने रोड के ऊपर उसको अप्लाई किया है। रोड जो प्रेशर से एनर्जी डेवलप होगा, उसके ऊपर से कैसा एनर्जी जनरेट होने वाला है, उसके ऊपर हम काम कर रहे हैं। और उससे
Right.
थोड़ा सा एडवांस ये है कि सेंसर यूज करके एनर्जी हार्वेस्टिंग भी करना है, और जो फिजिकली चैलेंज्ड पीपल है तो उनको ऑटोमेटिकली कैसे गाड़ी को सिग्नल रुकेगा और वो ट्रैफिक में पास करेंगे, दिस इज आवर सेकेंड। मैंने उसके लिए समथिंग 25 लाख का फंडिंग के लिए अप्लाई किया है। वो अभी तक रिजल्ट नहीं आया, बट वो पार्ट हम डिस्कशन करें।
Sir, what was the cost of smart road, sir?
व्हाट सर, प्लीज स्पीक
What
लाउडली।
was the cost of smart road? See, you said you did on.
Sir, we are just planning for that. We are not implemented. We are applied for that funding, for research funding, and then we are going to apply for some of the 10 to 20 meter road, and then we can decide the cost of that stuff.
Yes, sir. Yes.
You are using, you are converting the dynamic energy into this or what?
Okay, yes, yes. I am just going to show one video how we're going to do. Actually, just 1 minute. Sir. Just 1 minute. Can it is visible?
Yes, sir, it is.
Yes.
This is our concept actually. In that, if you see here, this is our plan. That this is the जो डिजाइन के लिए हमने अप्लाई किया था, तो दिस इज AI generated. This is all the total smart payment power storage, and we are here that patches will be provided in the road, and here what are the energy we are going to store in their system. एंड दैट एनर्जी दैट इज एआई जो डेटा सिस्टम है उसके ऊपर हम क्या करने वाले हैं, उसको अप्लाई करने वाले हैं. इट इज जस्ट इनिशियल फेज में है. मैं आपको उस दिन थोड़ा और डिटेल्स में बताऊंगा.
Yes,
Very good, sir. Very good.
very good, sir. Yes, anybody from audience?
Actually, this is our proposal that what is I am submitted. This is our proposal. This is total camera and how the piezoelectric signals are there. कैसे डिटेक्ट होगा वो मैं आपको उस दिन थोड़ा डिटेल्स में बताऊंगा. ये ऑलरेडी प्रपोजल हमने सबमिट किया है तो इसलिए मैं थोड़ा डिटेल्स में उसको नहीं बताया अभी तक.
इसमें आपके बी के स्टूडेंट भी है क्या?
ये हमारे बी के प्रोजेक्ट है. मैं उनको वो प्रोजेक्ट के ऊपर ही काम किया. खाली बी के ही लड़के हैं सर. ये जो
अच्छा,
4 लड़के मेरे साथ है वो बी के लड़के हैं. और
अच्छा.
डेटा एक्विजिशन थोड़ा स्मार्ट एआई के लिए मैंने हमारे एक इलेक्ट्रिकल के सर है जो रिसेंटली
Right, right.
NIT राहुल कला से PhD करके हमारे यहाँ पे ज्वाइन हुए हैं. मैं उनको भी इसमें इंट्रोड्यूस किया है. हम तीनों बी के 4 प्रोजेक्ट में और वो मिलके सब हम कर रहे हैं.
नहीं, अच्छा है सर, आपके लड़के और शायद मतलब नए स्टाफ भी कुछ कर सकते हैं.
एक्चुअली ये सारे जो मॉडल है ये सब जो डायग्राम है उन्होंने जनरेट किया है. विद इन लिमिटेड टाइम उन्होंने किया. दिस इज वेरी स्मार्ट है ना. आज शायद वो एआई के वजह से बहुत स्मार्ट है. इतने बढ़िया डायग्राम तो हमने ऐसे बहुत सारे उन्होंने किया है. और अभी जो रिसेंटली हमारे यहाँ पे आदानी साहब आए थे तो आदानी साहब के सामने प्रेजेंटेशन भी था वीडियो. उन्होंने कंक्रीट क्यूब के ऊपर हाउ दिस पीजेटी वर्क्स कंक्रीट के ऊपर उन्होंने एनर्जी हार्वेस्टिंग कैसे हुआ उनको डेमोन्स्ट्रेशन किए थे. दिस इज देयर. आदानी साहब also appreciated that work. और वी आर फॉरवर्डिंग. धीरे धीरे जा रहे जितना ये हो रहा है. ओके देखिए.
Sir, one more question.
Yes.
What is the cost of that data acquisition system?
मैडम वो डिपेंड करता है कि आप कौन सी एक्विजिशन सिस्टम ले रहे हैं. तो उसके हिसाब से अगर आप उसको ये करेंगे कि कौन सी एक्विजिशन सिस्टम है और क्या है उसके ऊपर डिपेंड करता है.
Means we have to write a proposal for that. मतलब ऐसे मुझे.
हाँ तो अगर आप डिजिटल ऑसिलोस्कोप लेते हैं मैडम वो वेरी करता है उसकी कैपेसिटी के हिसाब से.
Yes, yes.
तो आप कितना हर्ट्ज का खरीदना चाहते हैं क्या करते हो उसके ऊपर देखिए आपको मिल जाएगा. अगर आप गूगल में डालेंगे कि मुझे इतनी कैपेसिटी का डालना है डेटा एक्विजिशन सिस्टम तो उसके रेट आ जाता है मैडम.
Okay, sir. Thank you, sir.
और जो
Nice.
डीएसओ फ्यूज
Nice.
बहुत सस्ता बहुत छोटे से लेके बहुत हाई लेवल तक है. आपका वो फ्रीक्वेंसी के ऊपर डिपेंड है मैडम उसकी कैपेसिटी और फ्रीक्वेंसी.
Okay, sir.
Okay, thank you, ma'am. Hello.
हाँ सर.
Yes, sir. Yes, sir. It is very nice session and delivering wonderful thought, or valuable and helpful to our researchers. Some new PG student, also helpful to new staff. That is who are working or joining recently colleges or any research area. So I think in previous first or second session, I repeat again, there is a basic things like food, water, shelter, and AI is fourth one is our need, because without AI we cannot go with some new techniques. So thank you very much. Wonderful session and helpful to us. Okay, thank you. Yes, anybody from the audience और कुछ पूछना चाह रहे? शायद कोई है. Yes.
आज भी कुछ क्वेश्चन रह जाएगा तो सर सेकंड सेशन में जब हम कंटिन्यू करेंगे
Yes, yes, yes,
कैन
yes.
टेक द क्वेश्चंस. आप चैट बॉक्स से ले लीजिए.
Yes, yes.
Okay, sir.
Okay, sir. Thank you, sir.
Thank you, sir. Thank you once again, all the management committee, principal, and HOD of civil, Dr. Kate sir, Bobde sir, Dr. Bobde sir, for inviting such reputed and nice Atal FDP. This is my first experience actually. I'm little bit nervous, but it is okay. अगर कोई डाउट रह गया होगा या थोड़ा सा बोलने में कुछ प्रॉब्लम.
No, no, there is a one more session also remaining, na sir?
Yes, yes, yes. That is application part we are going to take.
उसमें जो भी है आप कंप्लीट कीजिए, उसमें और थोड़ा टाइम ले सकते हैं आप. No,
Yes,
don't
yes, yes. और थोड़ा सा लिमिटेशन हाँ होता है घाई गड़बड़ होता है उसमें.
No, 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 no issue. It's
हाँ,
okay.
और
सर उधर वॉल्यूम बढ़ा सकते क्या? देखिए सर थोड़ा.
Sir, volume is already on. Please your mobile or laptop
ओके
volume.
ओके
नहीं,
वॉल्यूम
उधर भी किया है सर मैं, इवन
मैं क्या
इधर करने से भी वॉल्यूम नहीं बढ़ रहा है सर।
अच्छा
इधर मेरा
ओके ओके आई विल
100% है।
डू दैट सर, आई विल डू
यस
दैट,
सर यस
नेक्स्ट टाइम ये
ओके।
करेंगे। और मेरा तो रिक्वेस्ट सबको ये रहेगा, जब डॉक्टर भल्ला सर ज्वाइन होंगे तो ही इज वेरी एक्सपर्ट एक्चुअली। उन्होंने चाइना से वो करेंगे, उनके ये चाइना से वो किए पीएचडी और बहुत अच्छे हैं। और एकदम डाउन टू अर्थ है। मेरे कॉलेज में वो 2-3 बार आके गए। मैं काटे सर को रिक्वेस्ट कर रहा था कि उनको फिजिकली बुलाइए, और ही इज मोर इंटरेस्ट डूइंग इन
फिजिकल
फिजिकल मोड
यस
rather than in online mode, but the FDP is not allowed to do that. So वो तो आने के लिए तैयार थे
नहीं
जब
नहीं बराबर है
मेरा ये
सर। ये
चालू।
क्या है, अभी नेक्स्ट टाइम हम अगर फिजिकली करेंगे
हाँ
एफडीपी
हाँ,
या जो भी, तो उसमें हम सर को भी बुलाएंगे और
यस यस,
एनुअल
श्योर श्योर
एक्सपेरिमेंटेशन टेस्ट चेक करेंगे सर।
श्योर। एनीवन, कोई भी अगर पार्टिसिपेंट से भल्ला सर को उनके कॉलेज में ये कर सकते, बुला सकते हैं, चाहते हैं तो ऑलवेज बुला सकते हैं। वो ऑलवेज वो हेल्पफुल है, और वो आप लोगों को हेल्प करेंगे। अगर आपको
यस
ये है तो मेरे माध्यम से भी आप कर सकते हैं।
यस सर यस सर। थैंक यू सर।
ठीक है, थैंक यू थैंक यू।
Thank you,
यस
sir.
ओके थैंक यू।
Thank you, sir.
So all participants, please fill the feedback of session.
सर
Five.
फोटोग्राफ्स नहीं लेते आप सारे कैमरा ऑन करके?
हाँ लेंगे सर। So please on your videos, all the participants. So as to we take this. Yes. Yes.
Okay, thank you, sir.
Yes.
थैंक यू
Thank
सर,
you, sir. Thank you, sir. Oh, so next session will start within 2 to 3 minutes. Our second one, session number 6, confronting issues, critical issues confronting structural design and professionals. So next speaker will ready within 2 to 3 minutes. So all should be ready and fill the feedback link of session number 5. So all should fill and be ready. Thank you. Hello. Hello.
Good evening to all. Am I audible, sir? Raut, sir?
Yes, yes, audible.
To the next session, the speaker for the engineer Shamrao Raut, structural consultants, BR Associates, Baramati, Pune. Sir has a member of Institute of Engineers, life member of Indian Society of Structural Engineers, patron member of Builder Association of India, life member Indian Institute of Bridge Engineers, graduate member of Institute of Structural Engineers. Sir has professional achievement for the since 2004 has carried out planning, structural designers, and more than 15,000 buildings and civil engineering structures, and covering more than 2.5 crore square foot of built up area covering major part of India. Sir has various types of structures plan design, including the residential, commercial, public, educational, industrial buildings, including modern age PEB structures, community halls, hotels, hospitals, all variety of religious structures, ETP and STP plants, machinery foundations, and miscellaneous structures for private and public sector, as well as railway, MIDC, PWD, and Jilla Parishad. Sir has worked as an expert or adjunct faculty for the various engineering colleges. Sir has various responsibility taken professional institutions, arrange workshops, seminars, and technical lectures through BAI and ISAC, arrange technical site visits for members of BAI and ISAC, actively taken participate in resolving and raising the issues regarding architecture, structural engineers, builders at various forums. Sir has attended various international, national, and state level conferences, meetings through IEI, BAI, and ISAC. Sir has taken lead for the formation of Ambuja Knowledge Center at Baramati. And Sir has various social contributions for the his native place, Wavar Hire, Man Tehsil. Also, then also he actively participated in Rotary Club of Baramati. And various Sir since 2004 also he have to provided the various structural consultancy services free of cost for the Baramati old age home. Okay, how sir? Over to you.
Okay. Thank you, Bobre sir. First of all, I will thank to College of Engineering, Malegaon, for giving me this opportunity, along with Department of Civil Engineering, Head of Department, Dr. Ingle ma'am, Dr. Kate sir, Dr. Bobre sir. So, starting with my session, critical issues confronting structural design and profession. As a profession, just a minute. Now, starting with the topic, what has been given to me, critical issues confronting structural design and profession. First of all, structural engineering is a special branch of civil engineering. So, structural engineering or engineers are often described as a backbone or skeleton of modern society, providing safety and stability for the civil engineering works. Without them, society would struggle to function and regress significantly. So this is the major branch of civil engineering, and for each and every work, it is very important. Now, the world, as we know, would essentially stop progressing and would struggle to maintain the existing infrastructure if all the structural engineers stopped working. Very boldly, I am giving this statement. Somewhen 4 to 5 years back, same statement was given by New York Times internationally about the structural engineers. That statement I have taken here. Structural engineers, when stop their work, the world will stop. So that is the importance of structural engineering. Their work is fundamental to the modern civilization and public safety. Then, in my view, each structural engineer plays the role of veterinary doctor. Why veterinary doctor? Because veterinary doctor deals with living organisms which can't speak, which can't express. So veterinary doctor has to assume each and everything, and he has to treat the animals like that way. These structures are non-living objects, but still any structural engineer has to assume them as a living organism or living object. He has to ask the structure, what are the problems, what is the load coming over it, where are the stresses developing, where is tension developing, and all the things. Like that way, any structural engineer has to speak with the structures, assuming it as a living object. That's why I have given this. He always deals with non-living objects, structures, considering treating it as a living object. Now, the subject is critical issues confronting structural design professions. Broadly, I have divided it into two parts. Firstly, technical and design challenges, and professional and industrial challenges. So these are two basic challenges in front of any structural design process or profession. So starting with the technical and design challenges, first, technical and design challenges. First challenge there is climate change and environmental conditions. Remember, whatever we are doing in structural designing or structural design process, there are two different things. We have to give shape and sizes for structural members, or finally, by using all the members, we have to define some posture. For that posture, we have to design beams, columns, slabs, whatever it may be, or any other structural members. So finally, it gives some posture, and each and every member that we have to design will be affecting by the natural loads and natural conditions, environmental conditions, and climate. It will affect the design. So whatever are the natural loads coming over the structure and what is the strength of structure, these are two different variables which never come together. Natural load coming over the structure has nothing to do with the original strength of the structure and material used. So this is very important point. Climate change and environmental conditions, now those are happening nowadays. Engineers must design structures that are resilient to, first, increased frequencies of extreme weather events, rising sea levels, significant temperature fluctuations. Now, what are the extreme weather conditions? If suppose floods are there, wind conditions are there, cyclones are there. One of the most critical condition that we assume, when earthquake happens there in the sea, then it creates the tsunamis. Again, we have to consider effect of the other. Rising sea levels are also affecting the structural designs. Again, significance of temperature fluctuations. Nowadays, now this is the season where we are observing in our region the temperature, whatever is the temperature in morning, doesn't remain same in the afternoon and again in evening. So temperature fluctuations are there, and those are mostly affecting the structural designs or behavior of the structures. So for that, this requires shift of traditional design methods to more adaptable and sustainable solutions. So we have to change our methods. We will have to consider secondary effects while designing the structures of temperature and these all natural conditions. Again, use of eco-friendly materials and integrating energy efficient designs. We have to consider energy, natural energy, and eco-friendly materials to design the structures. So this was the first point, climate change and environment conditions. Again, in technical and design challenges. Second point there is inaccurate load analysis. The fundamental issue is miscalculations. Now, what are miscalculations? That means assumptions. We have to assume some things. That means, yes, while calculating the loads and stresses, shear forces, bending moment, and effects of the forces. Some guidelines are there along with the IS codes and literatures. IS codes are the purely guidelines. Those guidelines are the outcome of so many peoples in the field who have given their total life for this particular field. Their experiences have been cumulatively taken in the IS codes, and these are the guidelines for us. But still, some miscalculations may be there, assumptions may be wrong one, and then this could happen. After that, underestimation or overestimation of the applied loads, which includes dead loads, as we know, these are permanent loads. Live loads are the occupancy loads, and dynamic environmental forces like wind loads, snow loads, seismic activity, all other loads. These loads are not frequent, or their dependence, their return period is different. But still, while calculating these loads for different use, we have to calculate these loads perfectly. If we underestimate the loads, then structure will be in danger. If we overestimate the load, then surely it will consume more materials and it will be more costly. And that we have to consider at a time. Now, third point there is foundations and geotechnical geological issues. The integrity of structure begins with its foundation. Common issues which arise from these conditions are improper information by the owner, contractor, architect for the soil data. Now what happens if suppose low-rise structures are there, some bungalows are there, small structures are there, then in those situations, always it may not be possible to have geotechnical and geological investigations. So in those situations, by knowing some basic data, we can design the structures. But still, structural designer must know, and he must have the study of geotechnical as well as geological issues for various soil conditions, for various rock conditions. There should be some thumb rules, there should be some ideas, his expertise to define safe bearing capacities, settlement conditions, all that. So improper, what happens, what is our experience is that whenever information is provided by the architect, contractor or owners, then there may be some variation or they may be giving vague information. So that is important thing. Again, another point there is inadequate soil testing. Suppose soil testing is done, then it may be inadequate. It may be misinterpreting. The soil reports may be misinterpreting. There may be some deficiencies. Again, failure to account for differential settlement, water tables, expansive soils. If suppose we take soil investigation, but still differential settlements, water tables, and expansive soils like black bottom soils, which are very important while deciding the bearing capacities and taking the foundations for the structures. Again, structural engineers must confirm and verify the soil conditions with proper expertise and judgment. Structural engineer has to work in the form of geotechnical as well as geological engineer also. He should know the aspects of these two fields. The next fourth point there is analysis methodology. This is very important. While analyzing any structure, civil engineering, we have to analyze it for various loads and its specific use. For any civil engineering structure or building, use may be different, and depending upon that use, we have to take the load considerations. And actual for area also, for different areas, the conditions are also changing. So proper job or site specific structural analysis methodology must be adopted. While designing and taking the loads, again, we have to consider site conditions and labor conditions at that particular area. Suppose I am designing any structure at Pune, Mumbai, then I am designing it for Baramati. And if I am designing it for the rural area, for all these locations, construction methodology changes, labor practices changes. So we should know the practice conditions there in that area, and depending upon the practice conditions of that area, we have to consider the design changes there also. Then next, there is complex analysis and material behavior. The use of advanced materials like composite, high performance concrete, and need to analyze complex structures requires sophisticated analytical skills and continuous learning. There is no any excuse for knowledge and analytical skills in structural engineering as well as civil engineering. Though we are using softwares, there is no any excuse for knowledge of the engineer. Software is tool which will help for designing the structures to speed up the design process. But still, you will have to analyze all the things, whatever the results are given by the software. For that, such study is required, and continuous learning process is also required. Then challenges include predicting the long-term performance, durability, and behavior under the varying conditions. Remember, though we are designing steel structures as well as RCC structures, but still, if we go for old structures, basically, whenever we are classifying the structures, if suppose any structure we are constructing by using mud or soil, it is having lifespan of 700 to 800 years because it is a natural material. If suppose we are designing any structure with the stones, again it will be having lifespan of 400, 500, 1000 years. We are having the examples of these various forts in Maharashtra, in our nation. If suppose Red Fort is taken, it was constructed somewhat 1300 years before, but still our Prime Minister are giving speech on for 15th August on the same fort. Ready? What is life of that? And whenever RCC structure and steel structures we are considering, what is life of that? Surely it is very less as compared to those structures. So again, these are the challenges for long-term performances and durability, as well as behavior under the varying conditions. That is fatigue, creep, shrinkage of concrete. These are secondary effects. Creep and shrinkage are the time-dependent effects, time-dependent. They cause the time-dependent deformations in the structures, and we have to consider all these effects while analyzing any structures. And these are the issues for structural designs. Then one of the point in that is stability and buckling neglect. Tall, slender, or long members are susceptible to sudden instability and buckling failures, which are geometry driven rather than the material failures. So, while designing any structure, we have to consider overall stability of the structure. Any plaza type building and any high rise building will have different conditions of stability. Plaza type building will fail directly by vertical collapse, but if suppose tall structure is there, it may rotate and failure may be due to instability. So we have to consider all the conditions. If slender members are there, long spans are there, we have to consider buckling effects. Sorry, there is some mistake. It is bucketing. It is buckling. After that, insufficient bracing and overlooking second order effects in analysis can lead to catastrophic results. So always we have to consider secondary effects while designing the structure. That means thermal effects, effects of creep, all those. Next, there is joints and connection detailing over the oversights. While designing the joints of any structure, maybe steel structure, RCC structure, or any other structure, joints are very important and critical points in design. Because whenever earthquakes or critical loads are there, joints must be well designed and rigid. So joints and connections are critical junctures where the forces are transferred between structural elements. Insufficient and incorrect anchorage, development lengths, insufficient bolt spacing, poor weld quality, etc. can create weak junctions, joints, supporting conditions may lead to failure. If suppose it is a RCC structure, you will have to provide sufficient development lengths, sufficient anchorage lengths. If suppose it is a steel structure, sufficient bolting and quality welding is required. So all these things are very important to form the, what do we call it as, plastic hinges. So joints are very important, supporting conditions. And if those are not properly designed, surely it will lead to failure. The next technical and design challenge there is aging infrastructure. A significant amount of existing infrastructure was built with outdated materials and methods, falling short of current safety standards. Now, today's designs are mandatory for earthquake conditions, but previously, suppose 20 years back or before that, it was not mandatory. So those structures were not designed for earthquakes and other conditions. Now, if suppose we have to strengthen the structures or we have to make compatible for today's use, then we will have to use new materials and safety standards for today's working conditions. So structural engineers face ongoing challenges of assessing, retrofitting and reinforcing these structures to meet the modern requirements. So we have to consider those things for today's conditions and we have to retrofit them, reinforce them. So this is again new challenge in these particular conditions. Then next issue considering technical and design challenges is balancing safety versus cost and efficiency. This is very important issue. Any structural design when carried out by structural engineer must be safe. That is the basic requirement. Any structure should be safe and sound, but at the same time it must be economical and cost effective. It should be durable, it should be efficient for the intended use. So perennial task of the structural engineer is to design safe and stable structure with economy. Both the things we have to consider at a time. Structure should be safe and stable. At the same time, it should consume less materials along with the economy. So over design structure, if suppose for security, any structural designer designs a structure which is over designed, may lead to wasted resources and increased or inflated costs. Again, if suppose any structure is under design or economical, may lead to over economical design with less safety. There may be less safety, danger may be there due to over economical designs. Again, may lead to continuous maintenance for its intended lifespan. This is very important point. Once we are designing a structure, if suppose while designing the structure, suppose today's cost is different and after 4 years, 5 years, 10 years, 20 years, a continuous maintenance is required. If suppose we have design under design or economical design we have given, then maintenance cost will be surely more, and certainly maintenance cost is more as compared to the construction cost. So this issue is very important for long time and durability of the structures. Maintenance and repair cost is quite higher over the long period as compared to the construction cost. So this point is very, very important. Structural engineer has to play in both roles. He has to consider cost as well as safety of the structure along with efficient use of the materials, and it should be efficient for occupants also. Structural engineer must keep balance of safety and economy considering the lifetime maintenance cost. This is again very important. Now, next technical and design challenge for structural design profession is adherence to the current and evolving codes, standards and bylaws. Now, there are different codes for various type of buildings, Indian standard codes. Again, particularly we are considering the buildings for state-wise and nation-wide. There is a national building code along with UDCPR is there for Maharashtra state and for different states also, they are having their own bylaws. Now, if suppose building codes, building bylaws standards are regularly updated to incorporate new research and safety features. These codes are continuously changing according to the requirements and new research. So structural engineer has to take consideration of these things also. Again, staying current with these changes and ensuring strict compliance for all the projects is a non-negotiable requirement. We can't excuse these things, codes as well as bylaws. Now, National Building Code, I will talk something about this National Building Code and bylaws implementation limitations. So first, town planning rules implementation. What happens in town planning rules? Side margins are for any buildings. Now what happens in market? Land is the thing which is not, it is fixed one. It is not multiplied. It is not a product. So land is a perishable item, suppose. So for any particular structure to be constructed, building bylaws are there and they require side margins for the plot. As the cost of the plots is increasing, land is increasing, size of the plots is becoming very small. Again, what I have observed, plots are such that they are having proportion of 1:2, 1:3 ratio in rectangle shape. Suppose 1 is the width, then its length will be 2 or 3 or 4 like that. So in those situations, if suppose major townships are not there, suppose large townships are there which are on the land of acres, 10 acres, 15 acres, 1 acre like that. But if suppose Guntevari plots are there, 2 guntas, 3 guntas, 5 guntas like that way. In those situations, this becomes very critical. So for safety issues, for fire hydrant issues, these margins are required by the National Building Code and building bylaws. In those situations, what happens when side margins are there, then building bylaws allows the cantilever balconies and columns are required to be taken on the margins only. So in those situations, due to side margins, floating columns are required to be taken, flared columns are required to be taken. These are very important effects. Again, location of lifts, effect of on analysis, enclosed balconies, water tanks and lift machine room, and their locations will define effect on earthquake design. So before explaining this, I will show you some plans. Sir. Next one. Can put it in. Plan. Video. Okay. Yeah. Now, I am showing a plan. Okay. Here is one apartment plan where the dark columns are the original columns coming from the footings, while hatched columns here. This C1, C7, here it is C21 and C27. As per requirements, here you can see this line. This center line I have shown, or margin line. This is the margin line for the plot. Beyond this line, it is not allowed to take the columns. That's why we have to take columns inside of this line. So column number C2, C23, C3, C4, C5, C6, C11, C18, C22, 26, 25, 24. These are inside of this line. Again, maximum limit is up to that line, but builder has taken again inside. Why? Because there are some issues of the car parkings. So what happens with this? See there, column number 23 and 2 is there. That column number 2 and 23 will be directly at the center of the room, at first floor or upper floors. So this is the obstruction here now. And this is due to the bylaws, not due to structural engineer. If suppose these rules are not there, then directly I might have taken column directly at C1 and C27 location. But due to the bylaws, I have to take these columns here. And since they are coming in the middle of the room, I have to cut it at the first slab level and I have make it as floating columns at C7 and C1. Again, C21 and C27. So like this way, floating columns are there due to the bylaws, not due to the structural engineer and other issues. So this is one thing. So I have to design these columns as floating columns, which are again taken from the beams directly. Those are huge beams carrying the loads and which are not allowed actually by the code. Again, one plan I could show you. Here it is typical first floor plan at bottom. The column locations I have shown. Now, suppose such a type of plan is there. See there, you can assume what is width of that building and what is length of the building. It is approximately 1:3 proportion. Here we can imagine the columns in bottom plan are required to float at first slab level. You can see here column number 1, column number 6, column number 5, column number 14, column number 19. Here 4 columns are there due to enclosed balconies. Again, it is because of the bylaws rule, not because of architect and not because of the structural engineer. These 14, 19, 6 and 1 are again in the middle of the room. So I have to float it. So this 14 number has been floated as FC7, 19 number has been floated as FC8, the 6 number has been floated as 6, FC6, C1 has been floated as FC1, C2, FC2, C3, FC3, C4, FC4. Now here I have taken it as a flared columns. Again, I can show you what are the flare columns. So you might have understood this particular condition. The columns at parking have changed their locations at first slab level because of the architectural use, occupancy of the owner and problem due to the bylaws. Here I can show you how the columns can be flared. Here one photo I can show you. See here, this is the building. Now due to bylaws, this column is there, here the column is there, here the column is there. And this has been tapered like this way. So this we are calling it as a flared column, and this is these are floating columns from that. These are the floating columns here. So whatever is shown here, here, these are the flared or tapered columns. This vertical load is transferred to this, and it will be transferred as a joint of truss. Suppose that inclined member will be in compression while horizontal member will be in tension, and whatever is the load here, it gets increased here. So this is only because of the building bylaws, not because of the structural engineer or owner. So these are the issues which any structural engineer has to face. Now again I will show you another building. फोटो शेयर होते हैं, फोटो शेयर होते हैं. Now this particular building here, 1, 2, 3, 4, 5, 6, again on the opposite side also, these are the floating columns. Again, this is very different thing. Now you can imagine this column. This is taken from foundation to first slab level. This is taken from foundation to first slab level, and this is the cantilever beam from which it has been taken up. So these are floating columns. So this is only because of building bylaws, not because of any other thing. Presentation. Okay. Now, so this is about floating columns, flared columns. Then again, lift locations and effect on analysis. This is very important again. For lifts also, how it affects the design that I have to show. See here, this is the building again, same plan. This line was of floating columns and this is a lift. Normally lift is taken in C shape, remember. But here I have taken two shear walls. Instead of taking this as a wall, I have taken it as a beam connection and on which we have taken a masonry wall. Here again two shear walls are there. How it affects? Normally what happens? For any building to be designed, structural design, while earthquake design is carried out, we have to take three modes. First mode, second mode, two translational modes are there and third mode is torsion mode. While designing the structure and making the model, third mode should be torsional mode. If suppose it is a first or second mode, then that structure becomes unstable and that is not allowed. But still for this particular building, it is not achieved because of this shape, planning and these floating situations. For second mode, there is a torsion mode. Again for next building, same issue was there. Here, again these columns are floating columns. We have taken these columns and here we have taken a shear wall. Again here it is a lift 9, 10, 4 and 3, these columns. Here again we have taken columns and walls of the lift we have not taken as a RCC walls only because of these are acting as a shear walls and which are affecting the design torsion modes. So location of lift which attracts more earthquake forces and it affects the design. So that is again important point. So here effect of earthquake on design. Here I have taken all the points: floating columns, flared columns, lift locations, effect on analysis. Enclosed balconies I have shown, water tank and lift machine room, same thing. So how location of these things affect or location of these columns, design of the building due to floating columns, flare columns, lift locations is affected due to the building bylaws that I have to show. Again, next there is architectural and owners' demands. Now, as per new code of what is required there for the columns. For previous code, the restriction of size was minimum 200, while for beams also, width of the beam was minimum 200. According to new code now, column sizes are different, width of the columns. They have taken aspect ratio into consideration. So for column sizes, what is required? The beam which is resting on the column, maximum size diameter bar into 20 times. Suppose 20 bar is there. So we have to take there 20 into 20, it is 400. So width of column will be 400. Again, aspect ratio issue is there. If suppose minimum width we are taking and we can't increase the length in any way. So we have to restrict width as well as length of the column because while taking the effect of earthquake, we have to take column strong in both the directions. So in those situations, they have taken some given some restriction for width divided by length should not increase 0.45. So column sizes, orientations and beam sizes, architect and owners demands are different and our codes are different. We have to follow the codes. Architects are never violating their building bylaws, but they are insisting structural engineer to violate all the codes, all the rules by the codes. Again, shear wall orientations, these are very important because for torsion mode, mostly shear walls are required because torsion is the surface phenomenon. For any member or for overall building, it is a surface phenomenon. So shear walls are required, mostly required on the periphery. But according to the planning, there are some limitations while giving shear walls to the building. Again, parking obstacle issues. Again, those flare columns, that is also not possible in all buildings to make them flared or tapered because whatever is margin outside the columns and between the compound, parking issues are there. Car there is a turning issue of the vehicles. So again, parking becomes an obstacle while designing the any building. Then plan variations from floor to floor. If plan is changing floor to floor, then column locations are very difficult. Again, dispute between the aesthetics and robustness. What happens? Architect demands aesthetics and structural engineer demands strength and safety. So what should we select? What to select, cosmetic look or strength and safety? That is again required to be defined. So these are the challenges in between architect, owners and structural engineers. Next, code violations. IS codes are violated by engineers, structural engineers, owners, builders, whatever it may be. Due to architectural and bylaws, law standard demands, it becomes very difficult to achieve the earthquake resistant designs. Again, not allowed by code, still required to take floating and flared columns. These things are not allowed by code, but we have to take to give the solutions. Again, loopholes in the codes and misinterpretation of the codes by structural engineers. Now, structural engineers are also searching for the loopholes. In previous earthquake codes, they have restricted width of the column for 200. So what our engineers have done, they have taken 200 as a fixed size, and as per their requirement, they have taken in whatever is the length of the column. So 200 by suppose 1200, 1500 as a column, it doesn't remain a column, it becomes a shear wall. Again, in one column, one direction it becomes very strong, while in another direction it becomes very weak. That's why new code has restricted this thing up to 0.45. So these loopholes sometimes are interpreted by the structural engineers also. Again, one thing I can tell you, suppose any beam we are designing, if it exceeds depth beyond 750, then it is required to provide skin reinforcements or surface reinforcements. 0.1% of the total cross-sectional area, we have to put equal distributed on faces of the columns. So 750 and beyond that. Again, for torsion issues, if suppose any beam we have to design for torsion, then skin reinforcement are required to be provided from 450 size. 450 and onwards, we have to provide skin reinforcements for beams for torsion design. So some designers, what they are doing, instead of taking 750, they are taking 700 or 725. So is it the way? Some transition is there, no doubt, but it is just on paper, 725 and 750. So by making difference of 25, we are not going to provide skin reinforcement. This is not the, what we say, this is not the design procedure. So this is misinterpretation rather than that. So these are the loopholes in codes also, and people are doing like that. So this is about the technical and design challenges. Those are coming while designing the structure for any structural engineer, and he has to consider those things. First, it was climate change and environmental conditions. Second was inaccurate load analysis. Third was foundation and geotechnical issues. Then next was analysis methodology. Then next was aging infrastructure. Then balancing safety versus cost and efficiency. And lastly, adherence to the current and evolving codes, standards, and bylaws. Now, next point, I can move to original point. See here. Technical and design challenges we have covered. Now it is professional and industry challenges while designing the structure and in profession. Now professional and industry challenges. First, there is communication and collaboration issues. First point there. Now, what is the importance of communication and collaboration? Any civil engineering activity is not a single individual's work. It is a teamwork. From technicians to the laborers. All these work, peoples are working together, and then we are creating something. So communication is very important. Communication may be verbal communication, communication may be written communication, communication may be from group to group, person to person. So this coordination and collaboration is very, very important in those situations. So effective collaboration between the architects, contractors, other stakeholders is crucial for the project success. Poor communication and a lack of coordination often leads to design flaws. If suppose due to miscommunication and lack of coordination, some data is missing, some data is misinterpreted, surely there will be flaws in the design. There will be mistakes in the design. Again, there will be defects and errors in the construction also. If suppose in any error is there in the design, that will be carried to the site. And same error, if it is not detected, then it will be carried forward and construction may be defective or errorful. Again, if suppose those defects are or errors are rectified, but it will take some time, surely construction will be delayed. Again, it will increase the cost. So all these are the linked conditions: design flaws, construction defects, errors, construction delays, again increasing the costs. So this is only because of the poor communication and lack of coordination in between the different agencies and person to person. This is very important in professional and industry challenges. Then second, there is professional recognition and value. Now, as far as structural engineers are concerned, structural engineering is concerned, it is a backbone, or which is not, what we can say, it is a backstage job. Suppose it is not focused, people are wasting money on suppose exterior finishing items, suppose finishing items, interiors, but owners and other peoples may not be giving that much importance to these issues: structural frame, construction actual, plaster, like that. So structural engineers often feel that their profession is undervalued compared to the others in the construction industry. Always some guilt is there, and due to that, it is not that much what we can say prestigious. Surely it is prestigious, but in terms of money, it is not that much prestigious. Then lack of public awareness about the critical roles and responsibilities of the structural engineers. Whatever designs we are doing, whatever calculations we are doing, whatever softwares we are using for designing the structures, whatever pains and study we are doing for that, it is, or all those calculations remain in computer or in offices. Their final outcome in terms of the drawings only issued to the site. So people doesn't know what we have done on behalf of the structural drawings. What are the calculations behind that? Architects, builders, owners, contractors doesn't know. So this is the lack of public awareness, what we are doing and what are the roles and responsibilities of structural engineering. Again, extremely low design fees as compared to the responsibilities and pains behind the work. It takes more and more time. Any structural engineer has to attend site, has to draw the plans, has to draw the drawings. As like architect, yes, surely I'm not defeating his job, but still they are drawing the, in their profession, only drawings are there and some concepts are there, thinking is there. But we have to make the drawings, we have to visit the sites, and we have to do the structural calculations also with exorbitant studies. Extremely low design fees as compared to the responsibilities and pains behind the work. So this is the professional recognition and value concern of the professional and industry challenges. The next, there is talent and skill gap. This is again very important. The field faces challenges in attracting and retaining the talent due to demanding educational path. Now, whenever we are considering structural engineers profession, nowadays minimum PG post graduation is required. Though graduation level is allowed, but still to have some better knowledge, better experience, it is mandatory, suppose, to do the post graduation. So that is the demanding path, educational path. Again, high liability. We have to take higher liability with less fees. Any structure when constructed as per Maharashtra government rules, is the responsibility for 30 years after its construction. It will be remaining on his record, or it will be the responsibility of the structural engineers. And after 30 years only, its stability will be checked. That is the rule. So just one can imagine the responsibility behind the structure. Again, compensation not always proportional to the responsibility and long hours. Here, job is taken in terms of square feet, not in terms of percentage also. So compensation, whatever is given, is suppose on square feet basis or like that way, or some lump sum basis. But job to job, time required for each and every job is different. Some jobs may be very complex, some may be very simple, but still to convert it into is difficult job. Again, loss of industrial knowledge due to experienced engineers leaving the industry. So since this is the hectic job, though talented engineers are there, experienced engineers are there, those are not interested in this particular industry. So they may be leaving the jobs. Again, this is for the structural engineers, but what about the other peoples? Whatever we are designing, we are giving in terms of designs or drawings. Finally, all those works are carried out by the laborers. Those drawings are issued to the directly to the laborers. So many times, our engineers are doing the job of postman only. They are taking the design from the structural engineer and directly putting the drawing into the hand of laborers or fitters and centering contractors. So what is his qualification? Centering contractor and his laborers. They have taken experience from his superior, not from any institution or like that way. So when drawing, they are receiving the drawing, they are opening the drawing. What they understood, they will do as per their judgment and their understanding. If suppose it is not, some feedback is not given by the engineers. This is very important. This is the communication gap again. So laborers didn't have, in our industry, laborers didn't have minimum institutional qualification like ITI. Though such courses are available in the market, in ITI also, mason, fitter, plumber, like that way, those courses are there in ITI colleges. But still, our peoples are not taking such trainings. Again, regular learning process of the laborers through the engineers is also important requirement of the industry. Whenever I am visiting the site, always I am insisting the laborers. First, I am giving him confidence that yes, structural engineer or engineer is for your help, not for your suppose what we can say that for giving him pains. So engineers can teach them at the site also. So regular learning process through the engineers to the laborers is very important. Again, contractors, builders should give free hand to the fresh engineers to apply their academic knowledge. What happens whenever any engineer comes out from the college, either by diploma or degree, whatever it may be, and he goes to the site towards any contractor, builders, and what he observed there, that one myth is there in the market that whatever is the academic knowledge and site conditions are different. No, it is not like that way. We are not applying the academic knowledge to the site. That is the drawback. We have to apply total academic knowledge to the site conditions by the engineers. And it is the responsibility of contractors as well as builders to give them platform at the site so that any new engineer, fresher engineer can do work there. He will have to make billings, he will have to make estimations, he will have to check the quality of concrete, not by judgment. Slum cone should be provided there. He should pour the concrete for cubes. He should test in the laboratories. Such a facility should be made available by contractors and builders so that he can apply the knowledge at the site. So this is again important thing. Then, as per my observation, what I have given here, just we consider last 40, 50 years, suppose. So what is change in tools of the engineers? So when when we were in colleges, now I don't know what is written there on the paper, question paper. But when we were in the colleges, use of slide rule and pocket calculator is allowed. So that was the sentence there. Now slide rules. I have also not seen what is slide rule. But before invention of the calculator, slide rules were there, log tables were there, and engineers have to do the calculations by using slide rules. After that, pocket calculator was evolved, so we have used that. After that, notepad was there. Again, laptops, notepads are there. Then software design was there. Softwares have been developed, and now we are moving towards the artificial intelligence. So this is the change within last 40 years. Suppose after 80s, we can say we have changed our fraternity from slide rule to pocket calculator to notepads to software design to artificial intelligence now. But within the same years, within the same period, what is the change? What is the parallel change? We can say, what is parallel change in the laborers' practice and workmanship of the laborers? This is the thing we have to consider. What is change in practice of the laborers? What practice we have changed at the site? Now we are using the software design. So many people sometimes tell me and ask me for software design. Now I can do both the things, software as well as manual designs. While insisting software design again, but what is the change in practice? I always ask them, what is your practice? What you have changed to mix the concrete there at your site? So I have to consider the conditions at site also while giving the designs. What practice they are adopting? We are having higher strength materials. Steel, now we are having 500 grade, 550 grade. Again, they are going to increase. Companies are going to increase. On one side, strength grade of the steel is increasing. At the same time, while increasing the grade of steel, strength of concrete is required to increase. But still, whatever was the practice 20 to 25 years before, same practice people are doing here. So demand for software design, but not interested in changing the work pattern at the site. This should be considered again. Now, last point there in professional and industry challenges is that technological advancements. Now, in our field, keeping up with the technology is changing continuously. So, rapid technological advancements like building information modeling, BIM, and artificial intelligence. Now, engineers has to study these things. These offers powerful solutions, but also require continuous learning and investment. Investment is required, learning is also required. At the same time, over reliance on softwares. While advanced softwares is crucial, it is not substitute for the basic fundamental knowledge. What I have told before also, softwares are the tools. Softwares are the assistant for engineers. They are going to multiply your speed of doing the work. But at the same time, you should question the softwares. If suppose any output we are taking, any engineer should question the software, how it is so. And it is possible only when he is having full basic knowledge, fundamental knowledge. There is no any substitute for engineer to fundamental knowledge. So many students ask me, sir, software will do the job. So this is not possible. Knowledge is not excused at the cost of software. Again, misuse and incorrect interpretation of the software outputs can lead to significant errors. Now, while doing the model, its misuse and incorrect interpretation will give you different results, incorrect results. So again, engineer has to interpret the results. He should know what is going on. Myself also in my office, whenever engineer comes to me designing the model, directly I told him so many times, this is wrong one. Then again he is saying that, hey, how it is so? Then after half an hour, 1 hour, he again comes to me and tells me that yes, you are correct. There was some mistake in modeling. So like that way, any engineer should have his hand on its fundamental knowledge. Again, such practice should be there to question the basics also. So these were the different aspects under professional and industry challenges. First was communication and collaboration issues. After that, professional recognition and value. Then talent and skill gap, and technology advancements. So these are the challenges which any structural engineer has to face or structural design has to face. And at last, before concluding, last but not least, we are the great agriculturist in the world. I'm using the special word, agriculturist. How it is so? Because we never insist our knowledge and decisions on others. Rather, we go on agreeing with anything which is insisted on us by the others. So we are agreeing with anything. We have to insist our conditions, our knowledge, our decisions on others, which are correct one. But still, we are not insisting these things. That's why the things are mishaps are happening. It is only because of the agriculture nature, AGREE. So okay, this was about the critical issues confronting the structural design and profession. From my side, thank you. I'm having some photos that I have to show. Hmm. ठीक. Now, there are different issues. Those might not be covered under this presentation. Now, these are some photographs. Now see here, 6-story building was there. And these are the concealed pipelines going through the slabs. Again, here, these are the things. These are also the issues in front of the structural engineering and structural designers. How work is done here. So for first slab, I have taken objection over this. So electrical contractor, he was also electrical engineer, has asked me to give me the solution. So I directly told him, I'm not an electrical engineer, I don't know, but I am knowing that this is very harmful for our slabs. So from next slab, what we have done, this totally have been cancelled and it is directly suspended from the slab bottom. One can imagine how the concreting could be there here. What about the bond of these pipelines and concrete? Here also, one pipe is laid above the other. What will be the effective depth of the slab? Here also. So here the pipes are running throughout anywhere. So this is a bad practice, suppose. See the conditions. Again, one thing I can show you. Now, these particular columns. This is as like jugglery. So this is the margin from the plot boundary. Suppose this is a compound, this line and this one. This is the required margin. So after that, these columns are required to be taken outside. So this is made tapered or flared. This load is coming over here and like this way. If we consider certain tie model or joint of a truss like that way. This is one condition. After that, this particular building again, there was some mistake by architect. While planning this building, what happened? 1 meter margin was lost. So I have designed this structure. This last slab was going on, and at that time, owner has noticed that extra margin was there. So again, plan has changed. Again, 1 meter margin is taken. So this is another column taken afterwards. This one, 1, 2, 3. Again, columns from that side. So this was the new column. Again, as per margin, this column is not possible here at this location. So it is required to float at first floor. So this column was new after this construction. Again, this is required to float. So this was the miracle, suppose. So what is done at that time? One video I can show you. Hmm. What was existing? Again, it was there. So these are the holes taken at that time. Because cannot be. So I was standing there throughout while doing this job. Here, this continuous firing of that was there. And afterwards, whatever we have seen this photo. So whatever you have seen, this was at this location. I was standing here. This was taken as a cantilever. This was the floating column, and this is the outcome of this that total effort. After that, again, what challenges structural engineer has to face? See, this is one of the apartments. Here, depth of the beam was 1.5 meter. Again, these beams. So this was one residential apartment. 50% part of the apartment was coming over a well of 33 feet. So whatever were the columns there. So again, those were not in the single line or in grid. So many beams we have taken. Outside the well was here somewhere. We have taken one column here, one column here, around about 50 feet. Here also one column, here one column. Then this was the beam, this was the beam, this was beam, this was like this way. Again, middle beams were taken. So you can imagine these things. And from these beams, floating columns were taken up. 50% of the apartment is on floating columns because we couldn't take foundation for this within the well because it was a field soil. Again, geotechnical problem. That soil might not be having sufficient strength. Its consolidation may not be proper. So that's why we have taken total columns outside this, and after that, over these beams, we have taken the floating columns. So like that way, so many issues are there. These very common examples I have shown here. So I think I have given sufficient information regarding this topic. What was expected from this particular lecture. So now I would request Kate sir to take the question answer session.
Hello. Yes, sir. Very nice and informative session regarding design of structures and what we say, actual construction practices, what issues and coming during construction activity or what we expect from them. So real solution can be found by who converting their efforts in particularly on site. That is a reality outcomes maybe give valuable and helpful to society, because our basic need is to fulfill the society needs as per their aspirations or maybe requirements. So thank you for valuable session on critical issues and confronting structural design and their profession. It's very difficult to challenges or difficult challenge in case of what we say uh, regarding our upcoming constructions and construction activities, allied structures. So thank you very much. So it is my request to participants, please on your video and discuss with your any questions or any other regarding this session. Thank you, Raut sir. Thank you. All the participants, please on your video and discuss with some sharing. You are also. Some people are maybe from what we say our education, but some people are delivering the lectures or taught the subjects, design of RCC steel or maybe some advanced design. Yes, Naik sir. Please unmute yourself.
Yes, sir.
Yeah.
I'm not currently having some question because many practical experience and practical views are shared with us today. So I just like to thank you all and Mr. Raut sir, as he is a site expert and very popular known structural consultant in Baramati. So thank you, sir, for sharing.
No issue, no issue. But
with
some relevant topic is very important that you may.
Yes.
It's okay, no problem.
Yes, sir.
Yes, any other?
Hello, sir.
Yes, ma'am, please.
Yeah, this is Dr. Manisha Wagmare from AISSMS College of Engineering, sir. Sir, your session was very good. You have shared very experiences, actual experiences. Though I'm from teaching background, I don't have that much exposure to the sites and the critical conditions. But I would just like to know that in some of the cases you have suggested the floating columns.
Yes,
And flared columns also. So in which code it is a permitted floating column? That because I have heard that the floating column is not allowed by the standards.
I also stated that it is not allowed.
Yes, sir.
In my lecture also 3 to 4 times I have stated that it is not allowed.
But still we are suggesting.
Suggesting problems are there. It is those are man-made problems. What I am saying, it is due to bylaws. When plots are very small, if suppose 2 gunta, 3 gunta, 4 gunta, 5 gunta like that way, then these problems are arising there. So many times I have addressed these problems.
So
And
in
when
that case, how the structural engineer would defend ourselves? Means how we should defend?
no any chance to defend directly.
Okay.
Structural engineers are assumed more brilliant persons by the industry. Remember, and what is our competition in field? If suppose myself and another consultant is there, again there is some competition of delivering such solutions, and people are requiring those. We
Okay.
can't say like that with change your plan. They will directly change the structural consultant.
Okay, sir. Yes.
Issues are there. We have to give the solutions. That is our job.
Okay,
We have
sir.
to give the solutions. So it is not allowed by the I have, that's why I have two plans there. How the plan was there, how the column was coming in the middle of the room. And this is everywhere. Not in Barabanki, not in Pune, not in Mumbai. Everywhere this issue is there.
Yes, sir. One more doubt is from curiosity. In the last, you had shown the construction where well was there. 50% of the structure or the building is
Yes.
covering the well.
Yes.
So in that case, have you taken any column or the pile foundation like that? What we
No,
should
no, no. I
suggest?
have done such 13 to 14 structures. Now, where I am living in apartments, that building was also constructed on well. And that was my first job.
Okay.
So, but that job was not given by me first. Again, consultant was from Pune. What happens at site? Remember, there was open well. It was
Hmm.
agricultural land,
Hmm.
and same person was the builder. But what happened there? Who was the designer there? He has suggested that please fill the well with soft material. We will take the pile foundation. But he has forgotten about the geotechnical aspects. Remember, whenever we are filling material, what about the some room or some loose material? Suppose it was 30 feet deep, and if suppose material we are filling now, what about the consolidation? What about its strength? And once it has been filled by I think some 3.5 lakhs, they have wasted there. And what they have told afterwards, yes, now cost is it will become most costly. 15 lakhs or 16 lakhs will be required for pile foundation. But that was not the issue. They have not, or they have kept in dark the builder. How? Because it was not possible in the field soil to take the piles. So better solution was that well was open. Lift is going up. Lift may down, go down in the well to take the columns at the bottom of the well. We can tie the column and afterwards we take the structural frame. But decision was over. And afterwards that job came to me. Then we have made geotechnical investigations by COP. It was horrible. The SPC was zero and liquefaction condition they have given. Again, builder has used fibro to compact that particular buildings are four or five buildings were there. So people have made complaint. Buildings are vibrating as like earthquake due to that vibration. But still, after taking its SPC, it was zero. Totally zero SPC was given and liquefaction condition was given. So in that situation also, I have taken two columns outside the well, getting 5 meter deep and floating that, and I am living there now. That was the assurance.
I
That
I I was curious because my house also in my village, my house was also built on the half part is built on the well.
okay.
So I was curious ki what exactly you had done because it was constructed before I became a civil engineer.
Again, one example I
So
can tell
I
you.
didn't know what exactly they have done, but what could be done, that was my curiosity.
I
Like,
can tell you. Whatever I have shown is a different way. There I show it was filled, and again one building I have 60 years before it was filled by soil, but still it was big. Again, in that situation also soil was not that much having capacity. So again I have taken columns outside. So many times this was happened.
thank you, sir.
Okay.
Yes, anybody? Shingade sir is asking someone. Yes, sir, please. यस सर, आवाज नहीं आ रहा है। हेलो। Sir, there is my one question, sir. From the site inspection, material selection, and the site selection and material selection, so many problem solving during the activities.
Okay.
But overall society is depending on only on structural engineer because they relying we safe because of structural engineer.
No. I can give answer to this.
Yeah.
Some 20-15 years before, suppose we have to construct a building or bungalow. People were saying that we have to go to engineer. There was not such a distinction: architect, site engineer, and structural engineer. Only engineer can do all the jobs.
Yes.
So what was that? Yes, engineer will give the solution. Now, every person, architect, owner, contractor, site engineer, all the people are saying whatever may be the problem. They are saying that we have to consult structural engineer. So now it has been put directly towards structural engineers.
Yes.
This is the issue.
नो सर, म्हणजे असं आहे की मी कराडला शिकलो, तिथं काही स्ट्रक्चरचे लोक होते, म्हणजे तुम्हाला माहितीच आहे, पंत सर, प्राणेश सर, की ते स्ट्रक्चर म्हटलं की सेफ, स्ट्रॉंग, स्टेबल हे 3 शब्द त्यांच्या तोंडात कायम असायचे.
Yes.
की आपण स्ट्रक्चरवरती रिलायबल काय, त्यांनी तिथं काहीतरी वाक्यरचना वगैरे लिहिलेली, संरचना, ज्याला स्ट्रक्चर मध्ये मराठीत म्हणतो. खूप काही चांगल्या गोष्टी त्यांनी पण तिथं आम्हाला सजेस्ट केलं. त्याच्यामुळे म्हणतो की सोसायटी ही स्ट्रक्चरल इंजिनियर्स वरती डिपेंड आहे, हे आपल्याला बऱ्याच लोकांना माहिती आहे.
At this time, I will remember Professor Dr. Madhav Kumtekar sir, when he was head of the department at Karad Government College. In last 15 days, he has expired. When I met him at first, when I was in PC, what he had suggested me, till today, I have remembered his sentence. He has told me that always rely on your calculations and calculators. What your mind says doesn't bother about that.
Yes.
Give the design 2 days later, it doesn't matter.
Yes.
20 years later, doesn't matter. But give it properly and don't change any word inside that drawing afterwards.
Yes.
Whenever I'm going to the site, if suppose one extra bar is there, I ask the people to remove that bar. It is not required extra. And whenever one bar is less, I ask to put it there.
Yes.
I never hesitate to tell.
Yes.
And that is the important. What Kumtekar sir has told me, that still I am remembering. You should rely on your calculations and calculator and basic knowledge.
Okay. Or anybody?
One thing I have to tell all people, whatever frame I have shown, never wish such frame like this way. On first, whatever you are observing there, this apartment designed by me, and not a single brick is there. For so many years, it was like that way. And we never get photo like this way. Normally what happens, upper slabs are going on, and from lower slabs, brickwork is good. So this is a bare frame. See the quality of work, construction quality. If we observe top beam for full length, and it's like totally perfect. That's why
Yes. Okay. Okay. Thank you, sir.
Thank you, sir.
Valuable guidance. Many more discussions solve our issues and some, what do we say, problems. So structural designer is not only problem solver, but also helpful to society and some needs. So thank you very much for your valuable guidance to our participants. So thank you once again. Anybody, participants, have any issue or any question? Okay. So tomorrow's session will start sharp 6 p.m. on 8th of January. Before or during that, one announcement is from my side. There is a one reflection journal topic is in our Atal FDP. So all participants kindly be ready during tomorrow. So I once again repeating on tomorrow's session. So all ensure with your feedback link and participants discussion. So fill your feedback link by both of them today's. Okay. Thank you to all.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you. All the participants, please on your video, we take a photo. Okay. Okay. Thank you. Thank you, sir.
Sir, can be left.
ये ओपन कर नहीं इस तरह शेयर चलो
Left to the list.
Stop. एक चीज अपने
Thank you.